Hey guys, so this is a nice little arithmetic sequences summary video, and I'm going to do it a little bit differently. I've already got it filled in. I'm just going to kind of talk you through it, but you're going to want to make sure that you get your notes filled out. So in class, we will have done a Desmos activity together about this, and then you're actually going to watch this video after you've done that. So this is our summary table. So we've talked about two different types of functions. We've talked about the recursive function and the explicit function. And here I've just represented what that thinking is. So remember, anytime you are finding the recursive function, you're finding, or using the recursive function, you're finding the next term. You have to know where to start, so you need some sort of initial term. It doesn't necessarily need to be the first term or the zero term, but it does need to have some term to start with. And you can get from one term to the next term, but you can't get to a future term without getting all of the points that are in between. The difference with an explicit function is that it will find you a future term. It doesn't require a specified start, and it can find any term in your sequence as long as you have the explicit function. So when you write the function, you do need a point to start with, but once you've got it, you don't need that other point to be able to use it. So think about finding the 50th term or the 100th term, you would use the explicit function. If you wanted to find the 20th term given the recursive function, if you have term 5, then you're going to have to find all of the terms in between 5 and 20 to use the recursive function. But for the explicit function, you would just plug in 20 for n, and you would get out what the 20th term is. So think explicit is future, recursive is next. So for example, when you're looking at recursives, you're going to have the directions and where to start. So all of these are examples of recursive functions. They tell you what to do and where to start at. In an explicit function, it still tells you what to do and where to start. It's just built into the function. So remember that this is where is your starting term. This is your common difference. And this is the term number of that starting term. Where in the recursive, if we look at this one here, here is our common difference, D. Here is the term number, and there's that term. When we're looking at it in a table, when you're using a recursive function, you're looking down the output column, and you're seeing how do I get from term to term. While in the explicit, you're going to be looking across the rows. Remember, we built out our tables to show how we were looking for that explicit rule. We want to be able to get from the term number to the term. So recursive, you're getting from term to term. Explicit, you're getting from term number to term. So they both have advantages and disadvantages. The advantage of a recursive function is if you're just finding the next term, just add to get to the next term. It's very easy. It doesn't take a lot of extra math. Whereas with the explicit, the advantage is you can find any term very quickly just by plugging into the equation. The disadvantages for the recursive, if you're looking for a future term, again, you're going to need all of the terms in between, so it's going to take you a little bit longer because you have to know the term right before the term you want. In the explicit, sometimes it's a little harder to see the pattern of change from one term to next. But remember, we've talked in class, whatever's being multiplied by the variable always ends up being your common difference because that's what you're doing multiple times, right? You're adding 4 or subtracting 4 for this one multiple times. You're adding 7 multiple times. You're subtracting 4 multiple times. So we've talked about this arithmetic sequence. So remembering that that pattern is adding, and it's specifically adding the same amount each time. So we could have an adding pattern, but if we're adding different amounts, that would not be arithmetic. It will have a common difference. In a table, you'll see that you are adding multiple amounts all the time. Remembering for recursive, we look down the table, so I did that in purple, well, darker purple. And the explicit, you look across the table from X to Y. I did that in a lighter purple. But you're always adding the same amount. So you see we're always adding 3. And then it'll turn into some form of a multiplication because multiplication is repeated addition. And we learned today that when we look at a graph, an arithmetic sequence will be a straight line of dots because there's nothing in between each of our pattern pieces, so it's always dots, so we wouldn't connect those dots. And because it forms a straight line, the function it'll match with is linear. So linear function that we'll talk more about in the next unit. And then here are your general forms for recursive functions. Remember, it'll be f of n is equal to f of n minus 1 plus your d value. And then just making sure to state your starting term number and what that term is. So I did not label that here, so that's your common difference. And this is the starting term number. And it could be 0, 1, 2, 3, 4, 18, doesn't matter. And your starting term. So it just needs to be any term to start with. And then in your general form of your explicit, you'll have this f of n equals f of n, f of some number plus d of n, d times n minus whatever. This whatever number should be the same here. But right here, this is actually going to be the term to start with. This is your common difference. And this is the term number of the starting term. So it actually ends up being, this is the green from your recursive, if we matched them. This is the pink from your recursive. And then the common difference is the blue. And making sure you get that sign. So hopefully this was a good review for you and a nice little worksheet to put everything together. Next week, we'll start talking about a different type of sequence, and we'll actually do another version of this with that other type of function, or sequence rather. So I hope this was helpful. Get it all filled in, and I will see you in class on Friday.